Hello and welcome to an introduction to SQL Server 2016's Query Store. My name is David Postlethwaite. I'm a database administrator for a large financial services company on the south coast of England. I've been working as a DBA for the last 7 years and I currently manage both SQL and Oracle instances. Previous to that, I was a developer using .NET, SQL, Access, FoxPro and Oracle, and way back in time I was a Windows and NetWare administrator. I'm an occasional contributor to the blog on gethanellis.com, and if you wish to contact me, my details are on the screen. The Query Store is a new feature in SQL Server 2016 that is designed to help us troubleshoot query performance. My aim today is to explain how Query Store can help you with your performance issues on your SQL Server. We'll have a look at what Query Store is, what it can do for us, the benefits, how it can solve real-world problems, how it works, what goes on inside SQL Server when it's running, some of the limitations and the best practices that you need to know if you intend to use it. And I hope by the end you'll be inspired enough to give Query Store a try. Now, before we get into Query Store, let me start by asking you a question. Have you ever experienced system outage or degradation which are expected to instantly fix? The database is responding slowly and the boss is standing over the top of you demanding you fix it. He's shouting, "Get it fixed, we're losing customers and money. Why don't you know what's wrong?" Have you ever been asked why a database slowed down this morning? Why did it? What changed this morning? What changed since then to make it go back up to speed? Have you ever upgraded an application to the latest SQL Server version and suffered performance issues? Microsoft claims SQL 2016 is 30% faster, so why has your database suddenly gone slow after you moved it to the shiny new server? Have you ever released new code and suffered a slowdown? New code should run faster, but when you've released it to production, it's going slower and you can't see why. Have you ever experienced unpredictable performance? 1 minute it's fast, the next minute it's gone slow. What is going on? And you can't see why. Have you ever wanted to track queries over time to see workload patterns, and changes from the baseline? Have you ever wanted to be able to answer quickly questions like, why has my query gone slow? What was the execution plan this morning compared to now? Why has it changed? Have you ever wanted to force SQL Server to use a different execution plan to the one it has now? You've worked out that SQL was using a different execution plan this morning. How can you make SQL use it this afternoon without having to rewrite code and keep it that way? Well, today could be your lucky day. So what tools have we used up to now to try and resolve these sort of issues? Well, many of us have used Profiler to capture traces of what's happening on the server. It's been with us since SQL 2000, and it can capture query performance metrics and other things and log it to a table or file. It can provide really useful information for a wide range of issues. But a trace can take quite an overhead on the server. Not always, but it's quite often the case. A Profiler isn't the sort of thing that you can run continuously on your server. You'll typically start it to capture some information, then stop it after a few minutes or an hour maybe. Trouble is, by the time you set it up and turned it on, you're probably too late to capture the problem you wanted to look at, and it will have mysteriously cleared, and you'll be no wiser as to what's happened. Now, extended events were introduced in SQL 2008. They were a major improvement on traces because they added a much wider range of events that could be captured. There are lots of things you can do with extended events that you couldn't do with Profiler and traces. But again, there is an overhead, and you have to start the extended event to capture the information you want. So many of the shortcomings of traces can be applied to extended events. Dynamic management views were introduced in SQL 2005. And these provide system-related data and performance-related data that you can easily query. DMVs provide a wealth of information, but again, we have some drawbacks. There's no concept of time. It's either real-time data or data since the SQL Server was last started. Your server may have been running for months, but you can't say, give me the data from yesterday or give me the data from an hour ago. And all the data is lost when the server is restarted. So if your server crashes, you will have no information about what happened prior to the crash. And if you have a cluster failover, this involves a server restart, and you lose the data in the DMVs, probably just at the moment you want it the most. So Query Store is a new tool in our armory to give you an extra layer of help. So what is Query Store? In a nutshell, it is a data recorder for your database. Once enabled, it automatically captures and retains a history of the queries that run on your system, their execution plan, and the runtime statistics. You can then use this information for troubleshooting performance problems. The metrics and data is held in a series of new system tables inside the database. This means that the information is available even after the server restarts, which is a great improvement over our DMVs. The information is automatically aggregated over a defined time interval, so you can now look at what happened an hour ago or last night, or see trends over the last month, rather than just seeing the sum or average since the server started, or what is happening right now. It works for nearly all types of query, including in-memory OLTP queries, which I believe aren't captured by DMVs at the moment. It's new to 2016. It's not available in older versions of SQL, and it's integrated into the SQL Server engine, so it's part of the normal processing and execution process. And the great news is that it's supported on all SQL 2016 editions, from Enterprise right down to Express. It also has quite a limited performance impact of around 3 to 5% on average, so Microsoft say, so you can leave it running continuously without causing too much of a problem on your server. It's enabled at the database level, so you can choose which database on a server you want to collect data, which means you don't have to collect unnecessary data and avoid unnecessary overhead. It's integrated into Management Studio. It's really easy to set up, and there are some built-in reports in Management Studio that allow you to analyze your queries and their performance. It includes several catalog views and extended events to access the captured information to create your own reports and alerts, and some people have used these to create their own reports in Power BI. So what can Query Store do for us? Using the built-in reports, you can quickly and easily find the worst culprits that are causing performance problems on your server. For instance, you can identify the most expensive queries in your database by CPU, execution time, memory consumption, reads and writes, and so forth. You can analyze the resource usage patterns for a particular database, see when the busiest times are and what queries are being run at that time, determine the number of times a query was executed in a given period. Audit the history of query plans for a given query. See if you have queries that are changing execution plan regularly. Identify all the non-parameterized queries so you can fix the code to use parameterized queries. And best of all, you can find all the queries that have slowed down, what Microsoft calls regressed. In other words, where a new execution plan has been created which is not as efficient as the older one. You can then easily force the server to use a previous execution plan, which will give you back the performance you had yesterday without having to write any code. So the easiest way to explain is to show you a Query Store in action. For this first demo, I'm going to use a Microsoft Azure SQL database. Query Store works on Azure SQL database as well as SQL Server 2016. If you weren't aware, all new features and bug fixes are first put into Azure SQL database, where they are tested and proved, and only then made available by cumulative update or service pack into SQL Server 2016. For Microsoft, Azure now comes first. So if I open up my list of databases, I have one here called AdventureWorks 2016. If I right click on this database and go to Properties, you'll see we have a new option here called Query Store. And this is where we can enable Query Store. We simply have to change the option called Off to Read Write. Query Store gives us a set of parameters which determine how large Query Store will be and how much data it will keep in it, and we'll discuss those in a minute. Down here you can see how much data is actually being stored in Query Store at the moment, and all we have to do is click on OK, and Query Store is now collecting data. There is nothing else we have to do. That is it. Query Store is now collecting performance metrics on our database. If we open up AdventureWorks, we have 4 available queries under this new option called Query Store. We have regressed queries, which can show us queries which are getting worse over time. We have overall resource consumption, top resource consuming queries, and tracked queries. So once you know a particular query that you want to look at and you've got its ID, rather than drilling through these different reports, you can simply type the number into the tracked query and go straight to it. So the best place to start is overall resource consumption. So if we double click on this, it will open up the overall resource consumption report, and here we can see the resource consumption that has been going on my Azure SQL database. I have a number of automation jobs running on Azure to actually create some data, so you can see how it's been varying over time. If you want to look at the actual numbers, click on Standard Grid, and that will show you the actual numbers of what's going on. But for a demo, the chart is definitely a lot more interesting to look at. Up in the top right hand corner we have a configure option, and here we can choose what metrics we want to display. So as well as the 4 that are on the screen, we can add logical writes, memory consumption and physical reads. We can also choose the time interval. So at the moment we're at last month, but we could change this to last week, and we can also change the aggregation side. So maybe I want to look at the last week by hour. Click OK, and that will now change the graphs to show how the resource consumption has worked over each in an hourly basis over the last week. And as you can see, my automation jobs only run at certain points during the day. I'm going to go back to configure, and I'm going to change this back to automatic. That makes it a bit easier to see. So here we are seeing the resource consumption over the last week for each individual day. So you can see it's been busy on some days and quieter on other days. If we hover over one of our boxes, we can see various information such as how much CPU, logical writes, memory consumption and the like that happened during that time. Once we've chosen the one that we want to look at, we can simply click on it, and it will open up the second report, this top resource consuming queries for that period that we've selected. And here we can see the graph of the top 25 resource consumers during this particular interval. If we hover over this particular one, we can see its query ID 898. It's come from an object called long query. I actually have a store procedure called long query that runs this particular query. In the time interval, it's been executed twice, and there is one execution plan. Down the bottom we can see that execution plan. We can hover over it and get all the normal execution statistics out of it. And over here we can see when it ran. So at 8:30 in the morning it was very quick to run, but in the evening it was very slow to run. And I know the reason for that is that at the evening one, lots of queries are all run at the same time, which swamps my little Azure SQL database and causes it to go slow. Up the top here, as well as being able to refresh the information as new information comes in, if we wish to, we can click on this button and it will show you the procedure that was actually running at that time, so that we can examine it in a query window. We can configure this just like we can configure the previous one, so we can choose what metrics we wish to see and what they're based on. We can choose our custom time interval, so we could choose the last 5 minutes, the last 30 minutes or whatever, as well as the custom time it's selected. We can choose how many queries we want to show in one go, and we may just want to look at ones which have more than one execution plan if we wish. So we have quite a range of options available to us. As well as that, we can change the y-axis to different values, and we can change the x-axis as well to show different values as well. So instead of the query ID, we could be looking at the object ID. And again, we can change here to show different values as well if we had enough data to display that. So there's quite a wide range of things that we can do. We can also change, obviously, from the drop downs as well. So there is plenty of scope for you to examine your queries, your execution plans, and your performance, and see the metrics and start to work out what is going on at the busiest time, what are the execution patterns that you're seeing over time, whether that's over the last week or over the last month. So these are a good starting point to give you a good overview of what's going on in your database. So naturally, you can enable and configure query store using T-SQL. This is a simple auto database commands. Just set query store equals on, and that will put it into read-write mode for you. The parameters that are available to you, first of all, you've got the operation mode. Read-write is the normal mode. Here it will collect and update query store with your performance data, but you can also set it to read-only mode. And in this case, no more data is added to query store, and no more data will be cleaned out either. But you can still read and query all the information. You might use this to, say, back up the database, restore it somewhere else, so that you can examine the query performance offline, causing any overhead on your current database. The maximum storage size, this is the maximum space that query store will use. Query store does not auto grow. So when this maximum is reached, query store will become read-only and stop collecting any more data. And we'll talk about managing space later on. So the default size is 100 meg, which will be a reasonable start for you. The interval length, this defines your aggregation that you wish to use. The default is 60 minutes. You can change it from anything from, I think, 5 minutes up to a day. That will depend very much on what you need to collect and how granular you need it. So the data flush interval, we haven't mentioned this yet, but initially the data in query store is captured and stored in memory. Then after a period defined by the data flush interval, it is written asynchronously to disk. So this option will determine how long it stays in memory before the asynchronous write to disk takes place. The default for that is 15 minutes. Now the capture mode, query capture mode, this determines what type of queries are going to be captured. So the default is all, which means it will capture every single query that runs on your database. The auto option, query store will try to decide which queries are worth capturing. It will try to ignore infrequently executed, insignificant ad hoc queries. But you have no say over what auto will do. That is a definition that is defined within query store and only known to Microsoft. You can also set it to none, which means query store will not gather information on any new queries. It will just continue to gather information on the queries that it knows about. The cleanup policy, this defines how long the data will stay in query store. How many days do you wish to keep? So the default is 30 days, a month. You may want to store more than that. You may want a year so that you can start comparing performance. And the size-based cleanup mode, this is probably one of the most important options. This controls the cleanup process. So if this is enabled, then query store will automatically delete data when query store becomes full, so it stops it going into read-only mode. The default is off, but Microsoft strongly recommend you activate the cleanup mode so that query store never goes into read-only mode. It always has room to collect the data. There's one parameter that you can't see in Management Studio, and that is the maximum plans per query. So query store will store, in this particular case, up to 200 different execution plans against each individual query, which I think would be more than enough. So what happens under the bonnet? Query Store is integrated into the SQL Server engine, so it's part of the normal processing and execution process. When a query gets compiled and executed for the first time, the query text and the query plan are sent to the plan store, and the runtime statistics of the query are sent to the runtime stat store. Each further time that the query is executed, the runtime statistics are updated and aggregated over the aggregation period into the runtime stat store. As we've said before, initially the data is saved to in-memory objects, and when the flush interval is reached, the data is placed into an asynchronous queue, and an internal process then writes the data inside the queue to the tables. By using an asynchronous queue, Query Store doesn't have to write the data to disk. The queue manages the write schedule, allowing Query Store to continue processing new queries without having to wait for the data write process to complete. The default flush interval is 15 minutes, which will give an average performance overhead of 3 to 5%, so Microsoft claims. If you lower the interval so it flushes more often, then you'll have a higher impact on performance. But if you have a longer interval, there'll be less overhead, but there's more risk of losing data that is left in memory in the event of a crash. In practice, the query text and execution plans are sent to the async queue straight away to avoid losing this information. It's only the runtime statistics that are kept in memory until the flush interval is reached. And a lot of discussions that I've read and blogs don't tend to point that out. They simply imply that both stay in memory for the full time. And some articles that I've read also suggest that new execution plans are written to disk quicker than the flush interval. So when you enable Query Store for the first time, or after you've purged all the data from it, it's common to see flushes occurring more often since more new execution plans are being encountered. So the flush interval should probably be treated as a maximum time rather than a specific time. Let's go a little bit deeper. Every individual unique query text is captured and stored as a separate entry. If you have multiple queries in your store procedure or function, they will each be tracked as individual queries. Each query consists of the query text and a unique combination of context settings, such as set options like set ANSI nulls or date format, or the object it was called from. Now there is a Microsoft web page that can give you all this information. There are a lot of parameters. If you want to learn more, I suggest that you go and have a look at that web page. If you execute the same query text with a different set of context values, then Query Store will record it as a separate entry into the query table. So if the exact same query text is run from two different store procedures, then there'll be one entry in the query text table, but two entries in the query table. Importantly, the exact text is used to define a query. So if the exact same query runs in several different places, but one has extra characters within it, such as comments, they'll be treated as different entries in the query text table. Each plan that is generated and executed during the lifetime of the query is stored separately. So you'll have runtime statistics for every single individual plan. This means if the query was executed with different plans, you'll be able to see what was a good plan, what was a bad plan, and what was the resource consumption of each individual query plan. Inside the runtime statistics, Query Store aggregates the runtime statistics for a query plan. This means that every unique query plan that was executed within the time window will be held as one aggregated row containing all the different metrics such as CPU consumption, memory, duration, reads and writes. If the query is run again in the same interval, it updates that row. It doesn't create a new row. You can access this data using these catalog views, so that rather than using the GUI, you can query these views to gain better insight into your plans. And there are plenty of examples of queries on the internet, and there are some on the gethanellis.com website in a blog that I have written about Query Store. When you query the Query Store, either through Management Studio or using the catalog views, the data returned is both from the in-memory objects and the data on disk, and they'll be presented as one merged set of data. Query store populates the data in this way. So if the query text is not stored, i.e. this is a brand new statement seen for the first time, then query store will create an entry in each table. If the query text was in query store and it's executed again, then just the query and the plan will be updated with the new information. If the query text comes into the store under a new context, i.e. it's got a different date format or it's from a different store procedure, then it records a new set of context setting combinations, a new query entry and a new plan will be generated. And if the query text is in the query store but a new plan is generated, then the query will be updated and a new plan created. For the execution process, when the plan that is in the store is executed for a new time interval, query store creates a new interval, generates the runtime statistics, and then records this information in the runtime stats table. And the last execution time is written to the plan store. If the query is run again in the same interval, it updates the statistics for that query. It doesn't create new rows. So if the query was run 10,000 times with the same plan, in that time interval there will be only one record in the runtime stats. And as already said, the data stays in memory for the period defined by the flush interval, and it's then written to disk using the asynchronous queue. This gives you some idea of the information you'll find in the different views. I couldn't fit every column that there is on the screen, but these are the main ones. So on the query plan side, you have the query text, query, context setting, and the plan view. On the runtime stats, you can see lots of metrics aggregated over the time window, and you'll see that it captures statistics for aborted queries as well as those completed successfully, both client aborted and those that have failed due to server error. So you can start analyzing your failed queries to see why they have failed. And what is updated? Any DML statement. Select, insert, delete, or update, however you do it, using a merge statement or whatever. Whether it's cached, whether it has a recompile query hint, whether it's an ad hoc query, even internal queries get collected. Everything else is ignored. It is just DML statements that are captured. Typically, query store usage will be divided into two types. Firstly, to look at performance and execution plans. What time of day do we see the most activity? When is our busiest time, morning, afternoon, or evening? How does performance vary over the last month? Is it getting better? Is it getting worse? What queries are causing the biggest performance hit on our database, which may need looking at? Are there queries that get cancelled by the user or by the system? Maybe work out why. Lack of resources. Users doing silly things. Maybe you have one of those reporting tools that allow users to design their own query without understanding the database and end up running an impossibly big query. Are there people running ad hoc queries? Are there non-parameterized queries that need looking at and converting? And secondly, use query store to find bad execution plans or too many execution plans and fix them by forcing the query optimizer to use a previous good plan. So let's now have a demo of how regressed queries work in query store. So this time I'm using a local database on my local PC. So first of all, I'm going to clear down query store and turn it off on my particular database. Then I'm going to turn it on and put it into read-write mode. And the reason why I clear it down as well as turn it off, if you just turn it off, the data stays in query store, and if I don't clear it down, then as I have found in previous demos, this doesn't work because it still has all the data, the forced plan from previous times. So first of all, I'm going to clear out the procedure crash. Do not do this on your production servers. I then have a fairly standard query. It's a parameterized query that is going to run on my AdventureWorks database. And it has a parameter here of name like k%. Now let me just turn on include actual execution plan, and if we run this particular statement, it should run reasonably quickly. It returns 15,000 rows, and if we look at the execution plan, if I pull this up, we have a fairly standard execution plan. So I'm going to right click and I'm going to save this execution plan to disk because we want to compare it in a moment to one that we already have. So in the wrong folder. So we'll call this SQL 1.execution plan. So this is the plan for this particular query. So let me clear out the procedure cache again, so there is nothing in memory. The reason I'm having to do this locally is that I found you can't actually clear out the procedure cache on an Azure SQL database, so I couldn't actually get this to work using Azure. So I'm going to run the same query again, but this time I have a slightly different predicate. This time it says H2R. So if I run this query, it takes a bit longer to run this time. It takes quite a lot longer to run. And this time, if we look at the execution plan, we have a different execution plan. One of the nice new features in SQL 2016 is if I right click, I can say compare execution plan, and I can pick up my previous execution plan, and we can actually see that they are different. And we have the ability to compare all the different parts of my execution plan and see how they're different. But it's effectively running exactly the same query, just a different predicate. But we do know that they are different. Now, if I go back and run my original query, which is this one with a predicate of just k, we'll now find that this uses the new query plan, which isn't as good. That has taken a lot longer to run, and it's using the new query plan, not my super fast original query plan. And that's not what we want. We want to make this query use the existing query plan, but without having to clear out the procedure cache and force a query to run that creates the right query plan, which is quite often how people resolve this problem at the moment. Now what I'm going to do is I'm just going to run a query against my query store, and you'll find out why in a moment. And that's going to return the query ID, number 1, because it's the only query recorded in there, of this particular query. So we can see the query text, and we can see we have two different execution plans. Now if I come over to Object Explorer, let's just shut down that one and go to my local database, go to Query Store. Let's just have a quick look at regressed queries, and I'll explain why we cannot see this regressed query in here yet. So if I double click on regressed queries, I open up the regressed query report. And if we come over to configure, you'll see why it doesn't work. So we can again choose what type of regression we want: CPU time, duration, logical reads and writes. Then we need to choose what interval we want to look through for our regression compared to the history that we want to look at. So I can look at the last 12 hours up to the last year, whereas here I could look at the last 5 minutes. The trouble is I've just run both queries in the last 30 seconds, so therefore it can't see that it's changed because we're still in that initial hour, which is why I can't use regressed query option to show you how this works. But this is where you would come if you're looking for regressed queries. and you will be able to see ones that have changed. So I'm going to close this down, because obviously I don't have any regress queries because we've only just started this one up. But now I know what my ID is, I can use my tracked query option. So I'm going to put in query number 1 and hit go, and we can now see over here my 2 runs. So I've got query 1, and it tells you how long it lasted for, which was the short time, and I have up here query 2, and we can see it's using the different query plan. We have the option here, again we can do our compare if I select both. So up here we have the option to compare plans. If I select 2 plans and click compare, I get to the same show plan comparison that we had before. So we can do that through our query store report. What we are going to do then is we are going to say I want to use this query plan. So I'm going to say force query 1 to use plan 1. If I click on force, are we sure? Yes. And there we are. If we now go back to my query store and I rerun my first query, this one with a K% in it, and click execute, we'll now find we are back using the original query plan. We have now forced SQL Server to use my original fast query plan, not my slow query plan. This is what Microsoft are selling as the real benefit of Query Store. Right, let's go back to the PowerPoint and carry on. One use case that Microsoft often quote is that of moving a database from an old version of SQL Server to SQL Server 2016. When you move your database to your shiny new server, Microsoft recommend leaving the compatibility level at the previous version and then allowing Query Store to run and capture a baseline of your query performance. Then change the compatibility level to SQL Server 2016, i.e. compatibility level 130, and then use Query Store to alert you on any queries which have degraded. As I'm sure many of you have found out, in SQL 2014 the query optimizer was completely rewritten and caused a number of issues for people when they were upgrading to 2014. So having this ability in SQL Server 2016 could make your upgrade plans slightly less painful. Another example that Microsoft quote is using Query Store to monitor updates to your application. Again, use Query Store to track a baseline for your queries before upgrading, and then use it to alert you to any queries which have degraded. This may require a bit more effort, because if the query has changed, even adding a new comment in the middle of the DML statement, then Query Store will treat it as a new query. So you'll need to use the catalog views and procedures to help you obtain the comparison. There are plenty of things to be aware when you start using Query Store. Not so much limitations, but things you must consider when you start to use it. First off, it's enabled at the database level. It is not a server-wide setting. This can be seen as a benefit because you can limit the databases you want to manage, so reducing the overhead caused by Query Store. But if you want to manage another database, you must remember to turn it on. And if you build a new instance, you must remember to turn on Query Store there for the database. And if you build a new instance, you must remember to turn on Query Store for the database you wish to monitor. There is no option to turn on Query Store automatically. Also, it cannot be enabled for either master or temp DB. People have tried, it just doesn't work. The reason this is important is that the query is captured in the context of the database. If you connect to master and run a query on your enabled database, Query Store will not capture the information. You must do a use database command to change the context to that database for Query Store to capture the information. So the default database setting for logins and in the connection strings from your application are going to be more important. You can't capture read-only databases, and this includes replicas such as always-on availability group secondaries. Many people use always on secondary databases in read-only mode for reporting purposes. You won't be able to capture the usage and statistics of these. There's no control over Query Store. Multiple DBAs could change the settings without reference to what others have been doing, so management could be difficult. Permissions-wise, if you have DB owner permissions, then you can configure, turn off, and change parameters and force execution plans. To view the reports and query the catalog views, you just need view database state permissions. There's no auto growth setting for Query Store like you find in SQL database. You have to set the maximum size you want the query store to grow to, and you must keep an eye on that size, because if it reaches its maximum size, it automatically becomes read-only and no more data will be added. You may find that Query Store isn't collecting data just at the time that you really need it. You have to keep a balance between the size and how much history that you really require. Check these parameters to ensure that you don't run out of disk space. A maximum size of 100 megabytes, which is the default, may not be sufficient for your workload, especially if it generates large numbers of different queries and plans, or if you want to keep a history for a longer period. The aggregation interval in your runtime statistics will directly affect the amount of data in the runtime statistics table. The default is 1 hour, which will give you 1 row per query, per plan, per hour. If you lower the value for finer granularity, the larger the query store will grow. If you change from 60 minutes to 1 minute, you'll have 60 times the amount of data. The stale query threshold defines the retention period for inactive queries. By default, Query Store is configured to keep data of inactive queries for 30 days, which may not be long enough, but you'll need more space. The size-based cleanup mode is the parameter which is probably one of the most important, because this will stop your database going read-only. If this is turned on, then Query Store will purge the oldest data when the database gets to 90% of its maximum size and delete enough data to get it down to 80% of its maximum size. By default, this is off, but Microsoft strongly recommends that this is activated to make sure that Query Store always runs in read-write mode and collects the latest data. You'll have to make sure that the maximum size is big enough not to lose the data you want. It will just remove the oldest data. It won't distinguish between what is worth keeping and what is not. The Query Store capture mode determines what queries are captured. So the default is all, and this will capture every single query regardless of how infrequent or insignificant they are, whereas auto just captures what Query Store thinks are queries worth capturing. Infrequent, insignificant queries and ad hoc queries are ignored. How it does this and what defines an insignificant query is not published. It's only known to Microsoft, so you may miss queries that you really wanted to capture. You can also set this to none, and in this case Query Store will stop capturing new queries. It will only continue to update information on the queries that it already knows about. Following on from this, are we capturing the data that we need correctly? Query Store reads all the text of a query, including any comments. If you have the same query in different places in your code, one with comments and one without comments, they will get treated as two different queries. If the exact same query runs in two different locations, then these get recorded as two different queries as well. The default reports treat these as two different entries, which will make comparison more difficult. You may have to design your own custom report to join the two queries based on the same query text. If you run non-parameterized queries, each query with different literal values will be treated as a separate entry. And in these cases, rather than gathering aggregated data about a query, Query Store will have split them into several different pieces of data. There is a query that can show you all your non-parameterized queries, so you can find them and then try and get them fixed. We've already mentioned that you must run query in the context of the database, otherwise Query Store will not recognize it. If you're running queries across multiple databases or with linked servers, you have to ensure that you're running in the correct context to capture the information. And as mentioned in the previous screen, if your cleanup policy is too short, you may not be keeping enough history for you to see regressed queries. There's no information on wait stats included, which may be of use to you to see why a query may have gone slow. You've only got one aggregation interval, which may not work for every query, and this is where you may have to have good management to stop one DBA changing the aggregation level to suit his query and another DBA changing it to suit his query. There is no context to the data in Query Store. You know when a query ran, what resources it used, but it won't tell you who ran it, or which program ran it, or where it was run from. So you won't be able to blame anyone for causing your system to go slow. The Query Store data is stored in the primary file group. You cannot change this. If you have all your user tables in the primary file group as well, then you may get file contention where Query Store is trying to write to the database at the same time as the users are trying to update their data. The database will naturally be larger for your backups and your restores. And forcing an execution plan is obviously what Microsoft have been promoting, and it does offer a quick fix, but is it a long-term solution? If you start using Query Store to force the optimizer to use a different query plan, you must go back and check that it's still valid. What if significant amounts of data have changed in the table, or a new index has been added? Is that forced execution plan still valid? You should see forcing a plan as a quick fix, giving you time to find a long-term solution, and make sure you periodically check what forced plans you have, otherwise you could be making the problem worse. Query Store is clever enough to see that if a forced query plan cannot be used, for example, you've dropped an index which that forced plan is using, it will go back and use whatever the query optimizer gives it to use. So it won't crash the system. It will carry on working even when a forced plan is no longer valid. Couple more points. If you release new code, it's really important that you alter the procedure and don't drop it. If you recreate a procedure, then you'll end up with a new object ID for your query, even if they are exactly the same text, so you won't be able to easily compare new with old. And also, don't rename a database. If you do, then any forced execution plans will break and Query Store will use whatever the query optimizer comes up with. So to summarize, Query Store is really easy to turn on, and with its built-in reports, very easy to see the performance of your database. You can identify the top queries by execution time, memory, consumption, etc., over a certain period. You can determine the number of times a query was executed in a given time window, audit the history of query plans for a given query, analyze the resource usage patterns. And you can fix queries that have recently regressed in performance due to execution plan changes. Even though it's been possible for us to perform many of these actions in earlier SQL versions, it's not been very easy. Query Store makes these actions far easier to use and available to everyone without the need to rewrite or manage queries in other ways. I hope this presentation has been of use to you. If you wish to contact me, my email address is on the screen. This is also available as a blog on the gethanellis.com, including a load of example queries for querying and managing Query Store. So thank you very much for listening, and I hope to see you again.